Hello. So today I will discuss about this H2O model, like fitting a deep learning model in H2O framework. So what is H2O? So H2O is very fast and a scalable open source machine learning platform, and several algorithms are available in it, like random forest, gradient boosting, deep learning, etc. So if you just fit any model in R and you fit the same model in H2O, like fitting a random forest in planar and fitting a random forest in H2O, then you will see the timing difference of fitting the same model will be very large. So H2 is very fast and it will take very less time in fitting the same model. So that is the use of using in H2O. And also it is very scalable. If you have more number of rows and you are increasing the number of rows, by that it is scale the time linearly, not quadratically or too much. So you can consider H2 as a very fast and a scalable thing. And I will go through the deep learning model here, and I will tell you about what are the parameters associated with this thing, right? There are a lot of parameters and you need to go through all those things. So if you have not seen my last video on neural networks in R, you should go through that, so that you need not go through all these things till this. And I will begin telling in detail about how to start H2O and how to fit the deep learning model in H2O in detail from here, right? So but I will go through what data I am taking is stored in package mass, so library mass, and you need to have the H2O package. You can install it using install.packages H2O. So once you have installed it like that, and you can import this library H2O. If you see that it gives no error, then you should be happy about it, that you have the H2O package with you now. So you have imported these two packages. So mass package will be having the data which we are interested in, and we are interested in the data Boston here, right? So we will store it. We can check this data here, right here, all these data, and also you can have a look on the data by writing the help Boston. So it has 506 rows, 14 columns, and we want to predict med v value on the basis of the rest of the variables, right? So I have already done the same thing in the neural networks in R using the neural net package. You should go through that, and then you should go through this video so that you have a good understanding about what's the difference between these two, and how the timing differences between these two kinds of models in H2O and all those things. So you can see the structure of data frame, and you have these numeric values and all these things, and we want to predict med v. You can plot the histogram. Med v seems like almost a Gaussian kind of distribution, but not perfectly Gaussian, but you can approximate it like this, because in deep learning we have to we have to tell about what distribution is it, and what loss function we are trying to optimize, and what metric we need to optimize for. So let's go through, and so that we don't make any kind of delay in starting that. So apply data frame to range that will give the low and high values. So med v is between 5 to 50, as you can see in the histogram also here, 5 to 50. Minimum is 5 and maximum is 50. You can normalize the data. Normalizing the data means you have different variables like this here, crim, z, and all these. We want to normalize the values in each of the variables so that the mean value in any of the variable is 0 and the standard deviation is 1. So for that you have to use this function max value, min value, and this. I have explained this in the last video, neural networks, but now the point here which we're trying to explain is about what is H2O and how to initialize it, H2O cluster in R, and how you can fit the model. So I'm giving a very precise video on this, so that you can have a beginning on this H2O, and you can start fitting the model on any kind of data. So if you have any CSV file, you can read it in that using the read.csv function, and the rest of the things will be remaining the same. I have used the inbuilt function, that is the Boston data, but you can use it for any kind of data. Now use the function h2o.init like this. Now say if you want to know what is H2O is, right, you should know that in H2O everything starts with H2O dot, and if you want to know, say, init, what is H2O.init, write question mark and hit control enter. You will see on the right hand side it says initialize and connect to H2O. So if you want to connect the R to H2O cluster, you need to use this function H2O.init. It will tell about all those parameters which I have used here, IP, port and mem size. I will explain you here. So IP, we are using the local machine. I am using a Windows machine with 8 gigabytes of RAM. So IP, you have to write localhost. If you are using in AWS, Amazon or cloud based server, then you have to change the IP and port so accordingly, but I am using a local machine to fit it. So you have to write the localhost, and port you have to write 54321 or anything the port you have, and the max mem size will be like this, 2650M. So I am using 2650 megabytes of my RAM available in my machine, local machine. I have 8000 megabytes of RAM, out of which I am using 2650 megabytes of RAM. You should not use all of the RAM which is available to the system. So you should at least leave 1 gigabytes or maybe 800 megabytes of RAM for the processing of the background processing for your machine. So this function will start the H2O cluster. So here you can see R is connected to the H2O cluster. It tells everything, total nodes, what 2.3 gigabytes of RAM I'm using out of 8 gigabytes, how many cores I have, 4 cores, allowed cores are 2, and all these things. So right, IP address, port, which I've given here. If you want to use it for more advanced things, so you can just write comma h2o.init, hit tab, and you will see all the options available. Right, now you write the target name, which is the Y as medv, target name, and then X, which is having the predictor names. I'm using the setDiff function, which will be taking the difference between the column names of data frame, all the column names except the Y, which is the target variable. So X and Y, these two things will be used in the deep learning model. It asks for X and Y and the training data frame. Again, what you want to do, if you want to see that how good the model has been fitted for the unknown data set, you can just do this training and data training data frame and test data frame, splitting the whole data into two parts, training and testing data. Now if you want to know what is h2o.deeplearning, you just write question h2o.deeplearning, and you can see here on the right hand side it will give you the whole detailed thing about what is h2o.deeplearning. It will give you about what is X, character vector, what is Y, character name for the column name for the target variable. X is the character column names of all the predictor variables, and training frame is the training data frame which you are using for fitting the model. So X, Y, you can maybe pause the video and note it all the things which are written here on the screen, so that when you do next time you don't miss the important things. There are other things also, but these are the basic things which are very important if you want to fit the deep learning model in H2O. So activation, you must be knowing that in neural networks or deep learning you have activation thing, and options available in with deep learning is tanh with dropout, rectifier with dropout, and max out, etc. Then one more parameter is there, input dropout ratio. It tells about the fraction of features for each training row to be omitted in training. It's similar to the mtry in the random forest. What does it do is it takes the random sample, random number of variables, random variables. Means if you have 10 variables, it will choose any 3 variables for each fitting of the decision tree. So if you are fitting 1000 decision trees in random forest, each time it fits a decision tree, it will take any random variable, 3 random variables. So it's like random sampling in the variable space. So input dropout ratio is similar to mtry in the random forest in R. Now if you are having any overfitting issues and the model is overfitting, you can have a penalty term in that, which is L1 and L2. L1, what does L1 do is it gives the penalty in the model such that all the weights becomes nearly 0, and L2, what does it do? It also gives the penalty, but it does not make the weights exactly 0, but it tries to approach to 0. So weights gets minimized to, and it tries to be approaching to 0. So none of the variable in the model will be over dominating, and so the model will try to learn from all the variables instead of just by just over dominance of some variables. So it's good idea to fit L1, use L1 and L2, but it's not a good idea to put a very high value of L1 and L2, because that will put a very high penalty on all the variables, and then model will not be able to learn anything from the variables. Now there is loss function. You can write arithmetic or cross entropy for classification, and there are also other, you can see here the loss on the right hand side. Yeah, loss. So what does loss says? Loss. So loss arithmetic you can use, or cross entropy for classification, or quadratic or absolute. So these are the loss function. It's best to write arithmetic. It is the cost function actually. So it is like a cost function, and it is a convex function or non-convex function. What kind of cost function it is, it will choose automatically. It's better to write automatic. So then we have this distribution of the target variable which we want to predict. If it is a binary variable for which we do classification, then we will use the Bernoulli. If it is a continuous variable, which we will do the regression. So if the target variable is a continuous, we will be doing the regression. So we will use the Gaussian distribution for the target. If the target variable is having more than 2 levels, then we will be using multinomial. More than 2 levels, or more than 2 classes. Similarly Poisson, similarly gamma. Now we have, for if we are doing classification or regression, you need to check it out. If we are doing the regression, you will be optimizing for MSE, mean squared error, or R square. Here you have a small r square for the same capital R square which we know. And for classification, you will optimize for AUC, area under curve, and log loss. So you should write the exact name in with the same uppercase or lowercase of the letters. Do not write in your words, but you have to check it out what's the exact case of this word. Then you have a stopping tolerance metric. So based on this, say if you are saying that if my AUC doesn't increase by 0.1 for an example, so you should stop. The model will stop iterating for the next iteration. So number of folds, so it takes the number of folds for the cross validation. So if you don't use H2O, you have to write other code for cross validation, or maybe use the caret package where you have the function for cross validation, or you write yourself for the cross validation. But in H2O there is an option available for the cross validation, and if you give the number of folds like 3 or 4, it will divide the data set which you are giving to the H2O, and it will do the fitting of the model and doing the cross validation in it, and try to optimize for the stopping metric and the distribution with the loss function which you have given. Also, if you are giving the penalty, it will take into account. So everything it takes into account, whatever the number of options are, all options are available, but you need to know that what you want to give. But this is a very simple demonstration of how to begin with H2O deep learning. I will be making more videos on giving a more detailed and more specific things, but this is general thing how to start with H2O deep learning. So right here you see x is equal to x, which is having the character names for all the predictor variables. Y is equal to y, that is the name of the column for the target variable. You put the seed 1 2 3 4 training frame, you write as dot H2O, that is converting the data frame into the H2O data frame. So as dot H2O is necessary so that H2O cluster knows that there is a data frame in H2O. So you need to convert the R data frame into H2O cluster form. So number of folds you give 3, stopping rounds you give 7, epochs is 400. That means it will the model will run for 400 times iterations. It will go through all the data 400 times epochs. So you should increase the epochs. You should begin with lower epochs and try to see what are the results, and then you can gradually increase the epochs. Override with best model, that is true. That means if it gets some model which is working very well, because it is doing the cross validation, it will check the validation metric validation predictions, that how well the model is doing on the unknown data set. So if it gets to know about any best model, it will give, this model will tell you about which is the best model in this. Then you give the activation. I am using the tan activation here for an example, and input dropout ratio is 0.1, that is 10% of the variable. Means there are 13 variables, predictor variables. Out of 13, that is 10% of 13 is around 1. So you are like, you can say the M try of the random forest is 2 or 3. M try is 9, because you are dropping one variable out of say 13 variables, so that will be M try will be 12. So you can maybe, it's just similar, it's not exactly same thing, but you can compare it with M try in the random forest. So don't give too high value, don't give too low value. You need to optimize all these variables, right? Also you need to optimize for how many folds. So you are giving, you need to check it out, what is the size of your data. And you don't, if the size of the data is very large, very small, and you're giving the number of folds as say number of folds as 2, then it's not good, because the data by which the model is learning is very less. So number of folds should be large in the case when you are having a very small data. Now we are giving the hidden, which is 10 10, which is saying that in the hidden layers we have 2 hidden layers. So one is having 10 hidden units and the other is having 10 hidden units. So the input layer is having 13 predictor variables, and the second layer has 10 hidden units. So, and the third layer has 10 hidden units, and the fourth will be the output variable, which will be bet v, right? So we are using 2 hidden layers with the units 10 10 in each of them. In the loss penalty term which we are using is 6e minus 4. L1 penalty I'm using, not L2. So you can choose what are the parameters you want to give. If you don't want to give, that's okay. Loss function you are putting as automatic, distribution you are using auto. Stopping metric is MSE, because we are doing the regression. Med v is the is continuous and we want to do regression, so we will optimize for MSE metric. So let's run this model. So it's running on the down, maybe you can see that it's running, and it's very fast. For 400 epochs it just take few seconds. So if you want to see what's stored in this model, now the name of the model is model, you want to see what's stored in the model, you just write model, check it out. Here it gives a very small it's a description, model details, H2O regression model. It's doing the regression, so deep learning is doing the regression. It's neural layers, it is using the Gaussian distribution. The distribution is Gaussian because we are doing the regression, and the target variable med_v is approximated by the Gaussian distribution, and the loss which is being used is quadratic function, quadratic loss. So 261 weights are there, which are interconnected weights. If you want to know how these weights are there, you please have a look on the neural networks in R, the previous video of mine which I have done on that. There I have shown the plot also of the neural network, how does neural networks looks and how these weights are connected to each other. Now here you see that first layer has 13 units, which is the number of predictor variables. Second layer has 10 units, third layer 10 units, and fourth layer is the target variable, that is the med_v. So input 13 variable, tan h is the activation which we have put, tan h is again activation, and then there is linear activation in the last one. Dropout is in the first layer 10%, then 0, then 0. Then this is momentum, and all these things I will be explaining in the next video about details about what does deep learning means and all those things. But this is for about how to fit a deep learning model in R. So let's do. If you go on downside, you see that reported on training data and MSE 0.0037. That's quite nice. That the mean squared error is approximately 0, and the R square is 90.8. That means this model is learning around 91%. That means R square is 91%. That means the variance explained by the model is around 91%, right? Only 9% variance is not been explained by this model. Now let's do the predictions. For predictions, you write predict model name, then convert the test data frame, and we are doing on the predictions on the test data frame as.h2o test data frame. You need to convert the data frame into h2o form, and you use the predict and then write it as .data frame to convert, right? So you see the predictions here. If you want to see the structure, a structure is very important. You should know that what the structure looks like of the certain object. Is it a list? Is it a data frame? Or is it a matrix? Is it a vector? What is it? The structure of predictions is like this. It gives the data frame. So if you want to access the predict column, you have to write predictions $predict. So that's why I said you need to check the structure. So it's a data frame of which predict column has to be accessed. So if you want to calculate the MSE manually, you can write predictions $predict minus test data frame med_v values like this. It gives the mean squared error, approximately the same value as the model is giving you. If you want to fit the predicted values and the actual values of the test data frame and the predicted values by the model on the test data frame, you can use this function. You see actual values are here and the predicted values are also here, and you are fitting them. These are approximated by a straight line which is a 45-degree slope. So it's so perfect. Mean squared error is approximately 0. That's quite good. That means the time taken by this model is also very less, deep learning model in H2, and also the fitting of the model is also good. Mean squared error is approximately 0 and R square is also approximately 91%. So that's good. But I am not talking about the optimization of the model for a certain parameters. This is just for beginning in H2 and using the model for any predictions, and this is the codes which you can use in any kind of general modeling. Like if you want to fit a model, random forest model, in your any data frame which you are getting from CSV file or anything, you can use the same code here. Just you need to write in the data frame, you need to read the data frame by read.csv. I am taking data frame as Boston, which is given in the mass. Right here, read.csv your file path. Then from now onwards, after this point, 13th point, you can use the same code for fitting the deep learning model. So let's have fun and have a look on this model, and you will have fun, that you will understand more on doing practice. So it's about practice. More you practice, more you learn. So thanks for watching. Have a nice day. Bye bye.